Okay, geometry students, in this video we will be starting Chapter 6. In this chapter we will be studying polygons. In Chapter 5, we spent a whole chapter studying one type of polygon called a triangle. In this chapter we will, put a little L right here, we will study a lot of characteristics of parallelograms, trapezoids, rectangles, squares, rhombi. Rhombi is plural for rhombus, rhombi, and more. Okay, so that's what chapter 6 is all about. Like a typical first lesson of a chapter, today we're going to look at some basic definitions of polygons and parts of polygons. Okay, the heading for today is Polygons, lesson 6.1, and don't forget to put today's date. Okay, be sure and include today's date. And let's continue on. Here we go. Like you probably thought, let's start off with the definition of a polygon. Okay, here it is. Please copy this down. Polygon, a figure formed by three or more segments, now listen carefully, in which each side intersects exactly two other sides. And where do they intersect at? The endpoints. Okay, I'll pause while you write this down. A figure formed by three or more segments in which each side intersects exactly two other sides at their endpoints. Okay, copy this down, please. Okay, let's continue on. I want to take a second and show you some figures that are and some figures that are not polygons. Okay? Now listen to me carefully, please. I don't think you need to take notes on this, but if you would like to, that's fine. That's okay. You'll have to draw the figures quickly because I am going to be moving quickly. But for the most part, it'll be common sense. I really don't think you need to take notes on this, but I will leave that up to you. Okay? Here we go. Now, I want you to listen to me carefully. All three of these figures here are polygons. Now don't fall asleep on me and don't think this is dumb, okay? I want you to listen, okay? First of all, notice that we have all segments. Straight line, straight line, straight line, straight line, straight line, straight line. Everything is a segment, okay? Now, look back here at your definition. A figure formed by three or more segments. Okay, so far so good. Each side has to intersect exactly two other sides at their endpoints. Notice that all of the sides here intersect at endpoints. In other words, you don't have an object like this. That would not be a polygon because look, you have sides intersecting right here, and that's not an endpoint. That's right in the middle of a segment, okay? So anyways, all of the sides intersect at endpoints. Okay, do you see that okay? All of them. And if I do something like this and stopped right here, that would not be a polygon because look, this segment right here is only intersecting one side right here. And look at your definition, in which each side intersects exactly two other sides. At their endpoints, it has to intersect two sides. So, all of these here are polygons because I have segments, and each segment is intersecting two other segments at their endpoints. Okay? Pretty simple. It really is, guys. Okay, now, let me show you some examples that are not polygons. Look at these. Okay, this one here. Why would this not be a polygon here? Because it's got a curved side. It's curved. That's not a segment. Okay? And so, because this here is not a segment, then this would not be a polygon. Okay? Look at this one. This is not a polygon because look, this side here does not extend and intersect right here. Okay? This would not be a polygon here because look, guys, see this segment right here? it's intersecting another segment, first of all, in three places. 1, 2, 3. And the definition says each side intersects exactly two other sides. Okay? But then also it says it's to intersect at their endpoints, and this one here is intersecting right in the middle. Okay, so this would not be a polygon, this would not be a polygon, and this would not be a polygon. It's not that hard. It's pretty much common sense, guys. Okay, but I still want you to see this. Okay, all right, let's continue on now. Okay, now again, you do not have to take notes on this. Just watch. I want us to go through and decide which ones would be polygons. Okay, very quickly. Well, this is a polygon here, no problem. We have all segments intersecting exactly two places at their endpoints. This is a polygon here, no problem. We have all segments, and all the segments are intersecting in two places at their endpoints. This would not be a polygon because the side here, right here, is not intersecting two other sides. It's only intersecting one. This would not be a polygon here, no, because look, this side here, right here, is intersecting right here in the middle. And all sides of polygons can only intersect at their endpoints. Okay? So that's it for that part of it there. Let's continue on, guys. It's pretty simple. And we're going to be looking at all kinds of polygons this year. Okay? So here we go. Now, there are two main types of polygons, convex and concave. Okay, I would write that down very quickly. Make note of that, okay? There are two types of polygons, convex and concave. We are going to be studying convex in this chapter, not concave. You don't need to write that down unless you want to. I'm just telling you we're going to be studying convex, not concave, okay? We will be studying convex polygons in this chapter, not concave. Okay, moving on. Now, I'm not going to make you memorize the definition of concave and convex, but I do want to quickly explain the difference between concave and convex. So please listen carefully and feel free to take notes on this if you need to. If you don't, just listen, but please don't talk and please don't disturb class, okay? Here we go. Now, here is a convex polygon. Something like that, okay? Here's the vertices. Here is a concave. Now, it's real easy to remember, guys. It's so easy to remember. Think about a cave that you would go into. A cave is the entrance into a mountain or into the ground, correct? And so a concave polygon has an entrance or an indentation like this, like a cave. Okay? Now some students get a little confused. They look at this and they say, well, from here to here, you went a little bit to the left, so it's like an indentation. And I really do understand that confusion. So here's the best way to know whether or not you have a convex or a concave. Are you ready for this? Here's the best way to know. If there's anywhere you can draw a line, anywhere, just one place that you can draw a line through the polygon that hits more than two sides, then it's concave. So that should eliminate confusion. So right here, I can draw a line here, and it hits how many sides? Two. So far, so good. I can draw a line here, and it hits how many sides? Two. So I'm good. But if I draw a line right here, it hits how many sides? 1, 2, 3, 4. So I know right away I have a concave polygon. It just has to happen in one place, guys. That's it. Or it only has to be one line that does this. Over here, men, women, I don't care if you draw a million lines. I don't care where you draw the line. Every line you draw in this polygon is going to hit the polygon in two places, unless you draw it right on top of a line like this. And I'm not really talking about that, okay? So there you go. That's the best way to know the difference between a convex and a concave polygon. And I might give you some of these on the upcoming quiz or test and say which one of these are convex, which one of these are concave. So make sure you understand this. Okay, again, pretty simple math so far. In fact, I remember in 8th grade, we covered this with you guys who are juniors right now. And so this is not too difficult stuff at all. All right, let's continue on. Let's go deeper now into our introduction to polygons. Polygons are classified by the number of sides they have. The number of sides. Okay? Now, in your notes, make a note. That's good. In your notes, make a note that at the top of page 268 on the left, you will see a list of the different types of polygons. So I want to encourage you to save class time and not copy all this down. And you say, well, all of what, Mr. Earhart? All of this right here, okay? I would hold off. I wouldn't copy that down. Just make a note in your notes that there's a list on page 268 on the left up top. You'll see it. That lists out the different types of polygons based on the number of sides, okay? And I think my list I'm going to show you now is not quite as long as theirs, but this is good enough. Here we go. Here's polygons. Here's the names of polygons based on the number of sides. 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, and so on and so forth. You can read these on your own. Okay, you need to be familiar with these and know these pretty well, okay? We're going to use them regularly. So if we're working on a word problem and it says the shape is a heptagon, you need to know that means that the polygon has 7 sides. You need to know that, okay? So we will use these regularly. You need to know these pretty well. I'm not going to ask you to list them or memorize them, but you do need to know these, okay? And really, this is the triangle you're used to. 4 sides, quadrilateral, pentagon. You know the Pentagon in Washington, D.C. Washington, D.C.? I'm not a history guy. Fairfax, Virginia. Anyways, the Pentagon. It's 5 sides. I always remember 6, like the number 6, 6, 6, like a hex. Okay, so hexagon. Heptagon. No trick there, I guess. Deca would be like decimeter in the metric system. Decimeter. Deca means 10. Octa, like an octopus, has 8 arms. Octagon 8, so on and so forth, okay? But we will use these names regularly, so make sure you know these really well and be familiar with them, okay? All right, continuing on, here we go. Let me stop here quickly for a second and show you how a polygon is named. You need to know this. Please write this down. If I have a really weird-looking polygon like this, write this down, please. Just write down something like that, okay? Notice every vertex has a letter. Okay? Now, when you name this polygon, you would call it Polygon, and then start with any letter you want. Doesn't matter. We'll start with E, and then you go clockwise around. So you call it Polygon E, D, C, B, A, H, G, F. Now that's an extreme example. We're not going to have any like that. But do you understand how to give a polygon a name? You name it by the letters of its vertices, okay? So you pick a vertex and go clockwise, all right? So you could call this polygon all of these letters here. Like if I had a quadrilateral like this, you could call that, let's call it X, A, M, B. You could call this Polygon X, XMBA, or you could call it Quadrilateral XMBA, or there's other names you can give this depending on where you start, what vertex you start at, okay? But that is how you name a polygon. Pretty simple, but again, you need to know that, okay? All right, let's continue on. Now, let's look at some terms that are quite often used with polygons that you really do need to know. Okay, are you ready? Copy these down. Let's move quickly. Okay, diagonal, a segment that connects two non-consecutive vertices. Okay, diagonal. Here we go. Draw this in your notes, please. Let's go with a pentagon. Okay, there we go. A really beautiful pentagon like that. All right, now, look, a diagonal could be this, and that's it. This would not be a diagonal from here to here. That's just a side of the polygon. This would not be a diagonal from here to here. That's a side of the diagonal, or a side of the pentagon. Guys, a diagonal goes from a vertex to another vertex, but it can be two consecutive vertices. It has to be two non-consecutive vertices. This vertex and this vertex here are called consecutive vertices, okay? Because they're side by side. Okay, you can't do that. But here's some more diagonals. Here's a diagonal from here to here, or from here to here. Okay, are you getting this okay? Here's a diagonal from here to here, or from here to here. Okay? And so the diagonals are a segment that connects two vertices, but they cannot be vertices that are side by side. Okay? And that's a diagonal. Let that sink in. It's pretty simple, guys. Okay? You are responsible for this definition, so please make sure you copy this in your notes. All right, let's continue on. Equilateral polygon, a polygon that has all congruent sides. Well, guys, that's it. I mean, if all of the sides have the same length, then it's an equilateral polygon. Pretty simple. Copy that down, please. If I'm going too fast, just have Miss Frampton or your supervising teacher pause the video, okay? Okay, equiangular polygon, a polygon that has all congruent angles, okay? A polygon that has all congruent angles. So if you have a polygon that the angles are all the same, then it's an equiangular polygon, okay? Regular polygons, a polygon that is both equilateral and equiangular, both, okay? A polygon that is both equilateral and equiangular. Pretty simple, guys. I'm going to pause, let you get caught up on these, okay? You need to know these, and you should be thankful you have to know these. These are easy on a test or a quiz. These are simple. These are easy points on a test or a quiz right here. And this one too, for that matter. Okay, now, let's finish up by looking at these problems here, okay? Let's go ahead and do this, and not that, and that. All right, here we go. Okay, this here would be, and you don't have to copy this down, because there's no need for you to copy this in your notes. Just sit back and pop some popcorn and watch the movie here and just listen, okay? Here we go. This quadrilateral is equilateral, but it's not equiangular. Because look, are all four angles congruent? No. But are all four sides congruent? Yes. So it's called an equilateral polygon. It's not regular because it's not both equilateral and equiangular. Look at B. Are all of the angles congruent? Yes. Okay, boom, 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 boom. Now you don't have to make those sound effects, okay? But you get the point. Now, are all of the sides congruent? Definitely. So this is a what? A regular polygon because it's both equilateral and it's equiangular. Okay? Which of the three is it, Mr. R? It's all three. You can call this equilateral, you can call it equiangular, you can call it regular. It's all three. This quadrilateral is equiangular but not equilateral. Look, we have four congruent angles. of the angles are congruent. However, are all the sides congruent? No. So it's not regular. It is not equilateral. It is equiangular. Okay, over here, are all of the sides congruent? Yes. But are all the angles congruent? No. So this is a equilateral polygon, or an equilateral heptagon, you could call it, but it's not a regular polygon, and it's not equiangular. Okay? Alright guys, that's it for today. I hope the video's been a help to you guys. If you have any questions, don't hesitate to call or email.